Matt from ECU Master here. I get this question a few times a week. People ask me, hey, how do I set up a base map, or do you have a base map for, this turbo, this engine, vanilla aroma air freshener? They give me a laundry list of modifications and want to know how to configure a base map or want us to hand them one. So we have general base maps for basic setups. We don't usually make one for each customer. We just can't do that. We can't keep up. So today I'm going to show you how to do basic changes to a base map for yourself. So what I've started with here, I started with our 1JZ base map. The 1JZ is kind of interesting in that the injectors are paired on 3 channels instead of 6. So let's say that this guy wired up his car to run all 6 injectors individually, so to run them full sequential. Let's say he's got a set of ID 1000 injectors, and he's got the base pressure cranked up a little bit. Let's say we've got 55 psi base pressure on his fuel pressure regulator. Then we'll say he's got like the LQ9 truck coils and staged fuel pumps. So we're going to start with the general base map. I'm going to show you how to make all the changes to get his car started and get it operating properly. So what I'm going to start with first is engine cranking fuel. I've done this in another video, so I've kind of shown you the general gist of it. As we see in the base map, the way it's configured, we've got a prime pulse, which means that it fires a little fuel right when it sees movement on the crank, when you engage the starter. I'm going to deselect batch all injectors. Batch means they fire every injector event, so 6 times for 2 crank revolutions. That's a lot on bigger injectors. We're going from a 370 to 1000 cc injector, so I'm going to deselect that. Make sure we use the injector calibration, which is the latency for the injectors. They're the dead time. And then I'm going to leave the fuel where it is, and we'll hope that's right. We can experiment with that later. That should be plenty of fuel to get the car started. If it's too little or too much, you can kind of hear it bog if it's too much when it starts, or if it takes too long to crank, doesn't start up, then start adding cranking fuel. Make sure you got a decent looking curve there. This one still could probably use some enrichment in the lower regions. For the injectors cowl, what we can do, the nice thing is we've got a little wizard for fuel. So we can open the injectors wizard and choose from a basic list of injectors. So we've got the data for ID 1000s at 3 bar, which is just over 40 psi. I want to do the data for a base pressure higher than that. So the injector data will change anytime you make a change to base pressure, because the more pressure there is across the injector, the differential pressure, the longer it takes to open. So I'm just going to close out of this and go over to my web browser, and I'm at injectordynamics.com. We've got the data here. Let's say we got 55 psi differential, so the base pressure is 55 pounds, and these are our latency values. So you can see it's in milliseconds. This is microseconds that they're showing. So in milliseconds, this would be 3.015. So go back to the software. That was at 8 volts, I believe. Let me double check. Yeah, 8 volts. That's 3.015. Double click this guy. And do that for each of the points we have data for, and then you can interpolate and make the curve look nice. I'm going to do it for 10 and show you kind of how that works. So 55 pounds, 10 volts, we got 1.815. And just go down the whole list and make a nice looking curve. We don't have data for these extreme low voltages here, but we can always just crank that up some by entering in a higher value here and making it look like a nice gradual curve. So I'm going to stop there. You can do the rest of that on your own. Since we are going to do sequential fueling instead of firing the injectors in pairs, I'm going to show you how to set that up. So we've got you see we've only got 3 injector events here. We're going to have 6 once we have them wired up to each channel. So I'm going to start here and just mirror the ignition outputs. So here you can see the normal firing for a 6-cylinder is offset by 1. That's just the way the triggers were configured on this motor. It's using, the middle cam sensor instead of the back one, so it's offset by a little bit. So we've got 1, 5, 3, 6, 2, 4. We just have 5 as the first one here, but it's all the same order, just offset. So we'll start with 5, 3, 6, 2. See, pulled up a warning box here. It's letting me know that with the outputs configured the way I do on this, we've got the fuel pump triggered by the injector for output. So I'm going to need to change that. So if you had a plug and play adapter, it's assigned this way, you'd need to remove the pin and move that to another output, one of the auxiliary outputs. So I'll sort that out right now. I'm going to move that over to, say, auxiliary 2. So that way I shouldn't get a warning when I do this, and I'll probably get a warning for one more of these. So it's 53624. And again, another one, so we need to move the main relay output to another channel. And 1. So again, go over to my outputs, main relay. It's giving me that red showing that I've got a conflict. You can also see that here when you go to show assigned outputs, that I've got conflicts on injector 5. It shows me the 2 channels it's assigned to. I'll move that over to auxiliary 1, and you just have to make sure to repin that. Oh, that's already used by check engine light. So let's see what else I've got. I can use auxiliary 5 or 6. Those are both available. So we'll say this is auxiliary 5 now. So hit make changes permanent, leave that as it is. So that sorts out our fuel injectors. Next, let's say that he's actually put in a 2JZ bottom end, so it's not a 2.5 liter anymore. Let's say that he's got a 2JZ block. That's as easy as taking the displacement and changing it like so. So that's the change there. And then also if we enter in our own latency data for the injectors, we need to enter the flow rate here. So that would be, again, at 55 base pressure, the flow rate would be 1135 cc per minute. So we just enter in and set that up as such. What else did I say? Oh yeah, let's say he's got truck coils. Those need a little bit more dwell time than the stock Toyota ones. Or let's say he just deleted the igniter and wanted to trigger the coils directly from the EMU, which you can do. The EMU has a built-in igniter, so you can run the coils using the stock igniter, or you can drive them directly. I can drive up to 6 coils directly. So if I wired them up directly, then just say no amplifier, your dwell times stay the same, no problem there. If we are using a smart coil, you'd say coils with built-in amplifier. Let's say that the truck coil is called for 3 volts or 3 milliseconds of dwell at 14 volts. We can just take this curve, multiply it by 1.2. So that's 1.2, hit the asterisk, and just increase that. Find the correct data for your coils. Don't just guess at this. I'm just doing a general overview to show you how to do this, but there is dwell information available for virtually any coil out there. You just have to do a little digging based on what you're using. The other thing I suggest is that let's say he's got 2 fuel pumps and he wants to stage the second one. So let me just find an empty table here. Let's say that he's got 2 fuel pumps. So we'll set up the first one. Again, we moved it to auxiliary 2. Let's say we don't need to run it for 3 seconds when the key comes on. Let's say he only wants to run it for a second and a half, just to prime the fuel system. And then we've got a second parameter output we can use. Let's say we use auxiliary 6 and use this to trigger the second fuel pump. And let's say that we want the RPM to be higher than 4,000 RPM. Hysteresis means that if this drops down below, it'll trigger once it's above 4,000, and it won't turn back off until it drops below, it'd be 3,500 for the lower end if we have a 500 RPM hysteresis value. If we drop it to 400, that means it's going to stay triggered until you get to 3,600 RPM. So just something to be aware of. We'll leave it at 500 just for giggles. We can also say and. So let's say we only want to run the second fuel pump when you're above 4,000 RPM and your manifold pressure is greater than, we'll say, 10 pounds of boost, or, something that's a rough estimate. Trying to convert that to kPa in my head. So it'd be around 170 kPa, if I'm doing my math right. And then hysteresis, again, we can pick, let's pick 30 for that. and that's it. We'll choose those two things. So we've got it set up. We set up the first two variables, which is RPM and map. So we've got, it's only active above 4,000 RPM, and it's only active above 170 pound or 170 kPa. And let's bring this down. The hysteresis value, we'll give that a bigger hysteresis because, when you shift, you don't want the fuel pump to turn off between gears. You want it to stay on, just because it's not as quick to respond probably. You just don't need that thing switching on and off all the time. So we'll say, give it just a gigantic hysteresis value. That way, it's not a problem. It's not going to switch off between gears when boost goes away. So that's that. So we've set up our coils, our fuel pump outputs, our injector data, and our displacement, all of our startup settings, or at least the basic startup settings. That should be enough to get you started up. Require some tweaking from there. But again, ignore this ugly calibration here that's not completed. But that's the general gist of it and should get you fired up. Thanks for listening in.